machinery up here, but hopefully we'll get this settled. The first speaker is my very good friend, Susan Hassel. And I don't think we have time to do big introductions, so I'm just going to go directly into the title. Susan's going to talk about telling the climate change story through framing and messaging. Susan. Yeah, we want to be Mac. And we want to start this.
Good afternoon. Can everybody hear me okay? So, we've been trying to tell the climate change story for a few decades. How many people think we're succeeding? Yeah, me neither. In fact, I think you could say we're missing the boat. So we clearly have a problem. And I think the problem looks a little bit like this. Here you see Republicans in red and Democrats in blue, respondents saying that the effects of global warming have already begun by party. So you'll notice that these numbers are almost the same in 1997. And then they start to diverge. Who knows what happened in 1997? Kyoto Protocol. Climate change became a policy issue. And I think a lot of the resistance that we're facing to the science of climate change is really about the policies that people are afraid of. And the fact that those policies, or they fear that those policies, threaten their values. So the problem also looks like this. If you're a Democrat, the higher your level of education, the more likely you are to see climate change as a threat. If you're a Republican, it's the opposite. The higher your level of education, the less likely you are to see climate change as a threat. Fascinating. This is from a study in Michigan, but the researchers who work on this say that it's extended pretty much all over the country. So, what's going on here? Are these people irrational? Well, Dan Kahan and colleagues have studied this, and they say no. These people are actually acting rationally at the individual level. There's a conflict between their individual rationality, which is, it's really rational for a person to take cues from his social group and his cultural group, and to want his beliefs and his ideas to conform to those of his social group. So those people are actually acting rationally at an individual level to reject the idea of climate change. It doesn't work out so well for the collective, of course. They also find, and this is fascinating, that like the last slide I showed you, the polarization increases with scientific literacy. So what that means is they tested everybody in the group's scientific literacy. They used a set of 8 questions from the National Science Foundation climate literacy questions, not just climate, all science literacy. For example, they asked, does the sun go around the earth or does the earth go around the sun? You'll be sorry to hear that only 72% of the respondents got that question right. But there was not much difference between the Republicans and the Democrats on that. But what they did find was that if the Republicans in that group, the ones that were more scientifically literate, like the last slide, the ones with more education, were more likely to reject the science of climate change. For Democrats, the opposite. So why is that? Well, it turns out that people are very good at conforming to the views of their cultural group. And people who are scientifically literate and numerate, which they also tested for, are even better at that. So is there any fix for such a problem? Well, the suggestion has been made that if you take an alternative angle on solutions, and especially if you make use of messengers who share the cultural values of the people that you're trying to reach, you will have a much better opportunity to overcome that problem. So this is not a brand new idea. People are starting to do this. We need to do it a lot more. And what you want to try and do is affirm rather than threaten people's values. So I started thinking about this, and I started thinking about the way I generally hear solutions framed, how they've been framed for a long time, for decades. And I kept coming up with words that looked like this: regulate, control, restrict. And I thought, I get it. I understand why people who have a certain set of cultural and political values would not be very happy with a set of solutions that look like this. And then I thought, there's a really different way of saying these things. And those kind of words look like this: ingenuity, innovation. Although I just heard the other day that Frank Luntz, the Republican strategist, says entrepreneur is out, job creator is in. That guy's a word doctor. Free market, by the way, they don't say capitalism anymore. He told them to not say capitalism because the Wall Street protests have gotten people to feel that that's negative. So now they use free market. But see, there's this whole other way to talk about the solution set. And it's much more inspiring. And I think it's something that pretty much everyone can agree on. So people are starting to try this. People have been trying it for a while. But here Secretary of Energy Steve Chu is invoking the frames of opportunity and competition, the clean energy race. I think it's an effective strategy. I think it's a good direction. So I just learned something else recently. Eco-America did this climate and environmental values survey, and they studied the way people look at different things. And they said that, you know what, many Americans see renewable energy and the way it's portrayed as very soft, very feminine, not very aggressive. And it turns out they don't really like this very much. It turns out that they like active, aggressive, and masculine images. So look at these other images. You have a guy rappelling down this enormous wind turbine, and you have this macho guy hoisting a solar panel on his shoulder. So this is the active, aggressive approach, a more masculine approach to renewable energy that apparently more Americans, and particularly those in certain value systems, seem to be attracted to. You can make all those other jokes yourself. I'm not touching it. So can we tell a more inspiring story? I think we can. One thing I want to say before I put this next picture up is, I am not saying we've been telling this story. But as Frank Luntz says, oh my God, I just invoked Frank Luntz for the second time in 2 minutes. That's really bad. I'm not saying we're telling this story, but some people are hearing this story. And as Frank Luntz says, it's not what you say, it's what they hear. And some people are hearing this story. And I think we could be telling that story. So instead of doing the I have a nightmare speech, we could do the I have a dream speech. We could be telling a story that's a lot more inspiring. So you might think, is she trying to get us to be advocates? Why does she think, if we're just trying to get people to understand the science, why is it important to tell them about solutions? Well, it turns out there's an interesting reason for that. Here's a study. They gave two groups of people the same set of information, two stories, both of them started the same, but they had different endings. One ending was about catastrophic consequences, it's inevitable, I don't think there's much we can do, it's hopeless. And the other ending was about a confidence in human ingenuity and a hopefulness. And it turns out that the people who got the more hopeful ending were much more likely to accept the science than the people who got the hopeless ending. Science was the same, and the questions they were asked were about the science, not about the solutions. So even if your goal is merely to get them to understand the science, if you include something about solutions, you're going to have a better chance of getting your science across. That's why it's important. Here's another reason. So, you know those customer loyalty cards? If you go to a car wash, you buy 8 car washes, you get 1 free. So the group on the left were given that card. The group on the right were given a card where they had to get 10 car washes to get 1 free, but they gave them 2 free stamps to get them started. So they obviously both had exactly the same goal, right? But the ones on the right felt like they had a head start. They were 20% of the way into their goal. And guess what happened? They got there faster, and almost twice as many of them got there. Amazing, right? So that tells us something interesting about human nature. And I think maybe that has something to teach us. So I like to tell people, you know what? That yellow line, that's California's per capita electricity consumption. That gray line, That's the U.S. as a whole. What happened in the mid-'70s in California that they were able to start bringing down their electricity consumption? Appliance efficiency standards and other energy efficiency measures. And you know what? They're not suffering. We're out here in California. I'm still drinking cold beer and taking hot showers. How about you? But look at it. They're already making a difference. They're using 1/3 less electricity per person, and they haven't sacrificed anything. That's another stamp on our punch card. Look at this. I just heard last week that last year, investment in renewable energy power plant was greater than investment in fossil fuel power plant for the year last year. That's good news. That's another stamp on our card. And when you look at cities where they are taking climate change seriously, where they're taking action to reduce emissions, what's happening in those cities? They're creating jobs. They're creating a great local economy. People are getting more fit. They're talking to their neighbors more. They're sending less kids to the hospital with asthma. There's a whole host of other great things that are happening because they're taking action on climate change. This is a wonderful part of the framing and messaging around climate change. And you know what it's doing? It's finding what works. It's finding the bright spots and scaling them up. So another really important part of the framing on this topic is to talk about choice and the choices that we face. Because I often hear people use the word inevitable or inevitability when they're talking about future climate change, and it really worries me. I think it's a dangerous word. Sure, we all know that a certain amount of climate change is already in the pipeline, but what we really face is a choice between a lower emissions future with less impacts, fewer impacts, or a higher emissions future with much greater impacts and potentially catastrophic effects if we stay on the current course. That's the choice we face. And I think it's really essential that we make that clear. I've been trying to convince you to talk about positive solutions. I'm not one of those people who thinks we can win the fight against climate change without talking about climate change. I do think we have to talk about the threats that we face, the climate change we're already experiencing, and how bad things are going to get if we stay the current course. We have to present both the threat and the opportunity. That's the choice we face, and I think we have to do that very, very clearly. So I also think we have to make clear the urgency, that this is a man-made problem and it has man-made solutions, but that there is a window of opportunity, and it is closing. I think we have to make that clear. I also think another thing we have to make much more clear to the wide variety of Americans is the really widespread agreement among climate scientists on all the basic facts of this. And you're going to hear a lot more about that from Ed Maybach today, so I'm not going to say any more about that now. So I want to mention that President Kennedy, when he was talking about putting a man on the moon and bringing him safely back, he said these words: "We choose to do these things not because they're easy, but because they're hard, and because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one we're willing to accept, one we're unwilling to postpone, and one which we intend to win." Now, those words could not have been written more appropriately for the subject that we face today. I think rising to a challenge is inspirational. Wouldn't you love to hear these words out of the mouths of our leaders today? I know I would. I think this is just the kind of framing and messaging that can actually help us overcome the deep cultural and partisan divide that we face on this subject, because everyone wants a better future. So I think I just want to make clear that I think we can paint a more inspiring vision of the future, one that taps into people's values, and a much clearer picture of the choice we face between the threats of climate change and the opportunities involved in addressing it. So I think I'll stop there. Thank you very much.
I couldn't help but think, as Susan was giving her talk, about the old Yogi Berra statement that if you come to a fork in the road, take it. What we're going to do is we're going to allow each of the speakers 15 minutes, and then after the four speakers do questions. But if somebody really has something really urgent, we'll insert it in now. But otherwise, we'll wait till after the four speakers are finished. By the way, I'm Don Webbles, University of Illinois. My co-convener is John Reisman, who's here somewhere, and he'll be speaking as well later. So what I'd like to do is eventually get all four speakers up here, but we'll do that after everybody's had a chance to talk. So the second talk will be given by John Cook. John is very well known for his skepticalscience.com blog, website. And today he's going to talk about effectively rebutting climate misinformation. Get this started. It's all yours. So you need to switch to PC.
It is on PC, but now how do I get my side up? Because it's a different side. All right, go there.
There, I do it.
And we'll go here. There we go.
Oh, there you go. That's what,
Easy peasy.
I'm a Mac person, so.
Now, there's one other problem. How do I control this?
Oh, use the arrows up here. I think the arrows on the keyboard.
That's controlling Susan's slide. I'll just use the
It's not this keyboard. Oh, there's another keyboard. You got to use this keyboard. We got to switch keyboards.
Sorry about this. A few technical issues.
We're still learning as well. How do we turn the lights down in the front? Can you find the gun? Thanks, Al.
Okay, hello. Let me just say it's a great pleasure to be at AGU, and it's very exciting to meet a lot of people that I've been corresponding with by email for several years now. Now, I run the website skepticalscience.com, and what I do with this website is we take climate misinformation and we refute it with peer-reviewed science. Now, while it was a great talk by Susan, and it would be an ideal situation if the conversation about climate was focused on solutions and the way forward. But the unfortunate reality is we do have to deal with climate misinformation, and climate communicators are more than aware that there's a lot of misinformation that we have to deal with on the internet and even in mainstream media and from politicians. So to effectively reduce the influence of misinformation, communicators need to be aware of how people process information and the cognitive processes that are involved when you're trying to debunk misinformation. So what I'm going to just explore this afternoon is just some of the psychological research about debunking misinformation and just some practical tips on how communicators can do it more effectively. Now, when I started Skeptical Science and started writing these rebuttals of climate myths, the way I thought about the human brain, I essentially used the information deficit model, and the way this works is, I guess when I went to debunk a myth, I thought of the mind as a well-ordered office with well-organised filing cabinets, and I would open up a file, take out the misinformation, and then add all the evidence that debunked it. And if that wasn't quite effective, then I'll just add more evidence until the job was done. Now, as it turns out, the human mind is more like this. When you attempt to correct misinformation, there's a number of psychological booby traps and obstacles that you need to look out for. And throughout the psychological literature, there are actually 4 separate backfire effects where when you try to debunk a myth, it can actually end up reinforcing the myth in the person's mind. I first learned about these backfire effects when I read a paper by Norbert Schwartz that examined exactly what happens when you attempt to refute misinformation. And what they did in this experiment was they tested these participants, tested their knowledge about vaccine myths, just to work out where their level of knowledge was. And then they showed them this flyer that I've got up here, which just debunked all the most common myths about vaccines. Then after about half an hour after they read the flyer, they then tested them again to see whether they could identify the myths from the facts. And the surprising result from this experiment was that some people actually scored worse after reading the flyer, and the debunking actually reinforced it in their minds. Now, the driving force behind this familiarity backfire effect is the fact that the more familiar people become with information, the more likely they are to accept that it's true. So when people first read the flyer, they remembered all the details about the debunking, and if they did the test straight after reading the flyer, they scored pretty well. But after a bit of time had elapsed, the details started to fade, and all they remembered was the myth. Now, when I first read the paper, I vividly remember this feeling of horror when I thought, is skeptical science reinforcing myths in people's minds, and I'm actually making things worse? But there is a way to minimise the familiarity backfire effect. And what you want to do is put the emphasis on the facts rather than the myth that you're responding to. So the last thing you want to do when you're refuting a myth is put the myth up in a big headline at the top of the page, at the top of your debunking. In fact, the researchers in Norbert Schwartz's paper recommended that, if possible, don't even mention the myth at all, but just communicate the facts. Another trap to watch out for is the overkill backfire effect. Now, normally you'd think, and this is how I started thinking when I started running skeptical science, you would think that the more arguments you give to show that a myth is false, the more successful you would be. But it turns out that the opposite can be true. In one experiment, which was actually in the same paper as by Norbert Schwartz, when participants were offered 12 arguments against a piece of misinformation, it actually ended up reinforcing the myth in readers' minds. Now, why does this happen? Now, processing a lot of arguments or a lot of information takes a lot of effort. So to a reader, a simple myth is more cognitively attractive than an overcomplicated correction. The solution is to not overload the reader with too much information. So the same experiment found that when they presented just 3 arguments against a myth, then they successfully reduced the influence of the misinformation. So it turns out that when it comes to refuting misinformation, less is often more. Now, the most powerful backfire effect, and Susan talked about this, and I'm thinking that John will probably touch on this as well, is the worldview backfire effect. And this happens with issues that tie in with people's worldviews and with their sense of identity. If you present evidence that threatens a person's worldview, it can often end up strengthening their belief in false information. Now, this was demonstrated in an experiment where the participants were Republicans who believed that Saddam Hussein was linked to the 9/11 terrorist attacks. And through the course of the experiment, they presented evidence to them. They chose this subject because there was overwhelming evidence that there was no link between Iraq and 9/11. And the evidence also included direct quotes from George Bush. Now, despite the overwhelming evidence, only 2% of the participants consciously changed their minds. And the vast majority of them persisted in their false belief. And they used a range of arguments to brush aside the evidence. And the most common response was attitude bolstering, which is bringing supporting facts or supporting arguments to mind while ignoring any contrary facts. And this resulted in their strengthening their false belief. Now, there's a number of practical applications that I took from this research. And the first is that it found that the backfire effect was strongest among the participants who were most firmly fixed in their views. So you stand a better chance of correcting misinformation among people who don't have their mind as firmly made up about these kinds of issues. So the approach we've taken with skeptical science is our target hasn't been to try to convince die-hard skeptics that try to change their mind. Our strategy is to present the evidence so that the undecided majority are not as influenced by the misinformation. Another way that information can be made more acceptable is by, and again Susan talked about this, is by framing the information in a way that's less threatening to their worldview. And I'll give one example which is a fairly semantic, shallow example, but there was research done where they found that conservatives were more likely to accept climate action if it was framed as a carbon offset rather than a carbon tax. And what was interesting is the choice of wording had little effect on Democrats or independents because their values are not challenged by the word tax. So I'm actually interested in what John's going to talk about and hope that you can go a bit deeper than just semantic framings. So that's a basic summary of the different backfire effects that you communicators need to be aware of. Now, let's say you manage to avoid all those different booby traps and backfire effects. There's one last psychological pitfall to look out for. Now, imagine the myth that you're debunking is like the golden idol in Indiana Jones in Raiders of the Lost Ark. Now, you can't just remove the idol. You have to replace it with an alternative. Now, this was found in an experiment where the participants read a fictitious account of a warehouse fire, and the account mentioned paint and cans, gas cans, along with explosions. Now, later on in the account, they corrected the information and said, no, there weren't actually any gas cans or paint in the fire. However, when the participants were asked later on why was there so much smoke, a lot of the people invoked the oil paint. And what's interesting is even when they acknowledged and they remembered and they accepted the correction, they were still influenced by the misinformation. So they said, yeah, like indicated in one answer that there was no paint or gas cans, but then when they were asked questions about what caused it, they would invoke them. So what's happening here? When people hear misinformation, they build a mental model, a way of understanding what causes the phenomenon. And when you debunk a myth, you're removing the myth from their mental model. And that leaves a gap in their understanding. Now, nature abhors a vacuum. So if you don't fill that gap, then people will fill it with whatever explanation is available. In the absence of a better explanation, people often use a wrong explanation. So an important aspect to an effective debunking is to provide an alternative explanation. In the experiment with the warehouse fire, when an alternative explanation involving lighter fluid and stationary was provided, then people were less likely to cite the paint and the gas cans. Now, a very concise, practical summary of all this research that I've just described comes from a book. Oh, hang on. I've got my slides in the wrong order. Let's jump. There we go. All right. Now, from the book Made to Stick, which I would highly recommend for anyone who's involved in communication. And what this book examines is what makes ideas sticky, what makes people take notice of them and then remember them over time. And at the end of the book, they address the question, how do you unstick an idea? How do you dislodge misinformation from people's minds? And their recommendation, fight sticky ideas with stickier ideas, which is a very concise summary of what I just spent 20 minutes summarising. So I will just jump. Have I got time to give one example? Or? Okay, just one quick example. I've kind of given away the ending there, but now I'll just give an example of using this model. Now here is a typical climate myth where they'll say that there's no scientific consensus because 31,000 scientists have signed a petition which is sceptical about human-caused global warming. And what's the core fact in response to this myth about no scientific consensus? the core fact is that 97 out of 100 climate scientists agree that humans are causing global warming. So but if you tell people this, then there's that, you create that gap. Like they'll think, well, how can you say 30,000 scientists sign this petition when there's a 97% consensus? And to the alternate explanation, to fill that gap, you explain that 99.9% of the people who signed that petition project are not climate scientists. So if you can't quite make him out, he's the little green fella in the bottom right corner is the climate scientist among that survey. And this technique of raising fake experts is not a new technique either for groups that deny science consensus. And we've seen it before in the 70s when the tobacco industry also cited large numbers of scientists who denied the consensus. Thanks very much.
Very good. Thank you, John. So our next speaker is another old friend, Ed Maybach. Ed's going to talk about improving the effectiveness of communication about climate science, insights from the Global Warming 6 America's Audience Segmentation Research Project. Ed?
Where is the switch to toggle?
The Mac. You need to get her talk off of there and yours on. So this is the keyboard you need.
I'm gonna let you do that. Oh, I see.
Back to one.
And
That's the mouse.
this is the mouse.
So pick your file
Switch
there.
these.
So this was a more complicated task than it
Oh,
first
yeah.
appeared.
It's awful.
All right.
There we go.
I think that was the window you needed, actually. That one's mine. You just closed the window that had your folder. Go to presentations. And open up my pack. So spread that open. There you are.
Bingo.
And open it up.
Excellent. Thank you. So I cannot tell you what a pleasure it is to be on a panel where my co-presenters are actually reinforcing the very same points that I am eager to present to you, as opposed to being the only one of my kind, which is usually the way it is. Noah showed the great good sense to at least bring two of each kind along. Don and John showed the good sense to bring on 4 of our kind, which is really a wonderful thing for us. So I'm actually not going to talk to you about Global Warming 6 America, but instead I'm going to talk to you about our work in the Climate Change in the American Mind research project. Got quite a lot of my colleagues who are part of this project. I'll introduce them to you in a moment. But I want to leave you with 3 points today. I want to make 3 points. The first one being about trust as your most important asset. The second one, as we've sort of seen modeled already here today, the less you say, the more you are heard. It's a paradoxical finding, but true nevertheless. And the more we understand it, the better we will become as effective communicators. And then the third and the final point I want to make is that we shouldn't be winging it. If the stakes are high and it's important that our communication is effective, we should mobilize the science of communication research to figure out what best to say rather than just fly on instinct using our gut. So this story begins with my colleagues and my research, Climate Change in the American Mind, which spun off the Global Warming 6 America's research project. I see my colleague Karen Akerlof in the audience. I'm not sure if any of my other colleagues are here or not, but they are Tony Leiserowitz, Nick Smith, and Jay Himilowski at Yale, Connie Roser, Renouf, Justin Rolf Redding, Karen Akerlof, Teresa Myers, and others at George Mason. So the first point, I know that we are taught in graduate school that knowledge, that expertise is our most important asset. Actually, it isn't so. Trust is our most important important asset, when it comes time to sharing what we know beyond the relatively small community of other like-minded experts, our expertise tends to get in the way of effective communication, and our lack of trust can either carry the day or serve as a fundamental impediment to our ability to share what we know. In the absence of trust, effective communication does not occur. Fortunately, Americans do trust us. They do trust scientists. In general, you'll see from this slide that while trust in other public institutions wax and wane, trust in us as scientists tends to be relatively steady. This is over the course of a number of decades. You see that you are among the most trusted institutions in America. But even keeping in mind that you are near the top, it's still only about 40% of Americans who place strong trust in you and your colleagues. So you are trusted, but there's room to be more trusted. With regard to climate change and you as a source of information about climate change, we've conducted quite a number of national surveys to look at the degree to which you are a trusted source of information, to look at the degree to which some of your collaborators, your funders, your competitors are trusted sources of information. The good news is that you are very trusted. You are among the most trusted, and your funding agencies and the government agencies that you collaborate in your research with are also trusted. But again, I want you to notice that the glass is not even quite half full there. Only about 20% of Americans place strong trust in you as sources of information about climate change. About 80%, 4 in 10, place some trust in you. But I would hope we aspire to become strongly trusted, greatly trusted by the vast majority of the American people, but we got to earn it, okay? That's my important point. So when others, this was not one of our surveys, but when the folks at Research America conducted a survey recently and they asked folks, well, can you name a single living scientist? What you can see on this slide is that essentially 2 out of 3 Americans are not even willing to try to name a single living scientist. Of those 1/3 who are willing to gamely try, if you look over at the right-hand side of the slide, you'll notice that some of those people are, if they're still alive, it's not exactly clear how they are still alive. I'd put Albert Einstein, Louis Pasteur, Marie Curie, and a couple of others in that category. So the point being, my point being, that when Americans tell me in response to our surveys that you are their most trusted source of information about global warming, about climate change, this is who they're thinking of. This is essentially the caricature that Margaret Mead 50 or 60 years ago discovered that cultures around the world, when asked to draw a picture of a scientist, they essentially draw this fellow. He's older, he's white, he's bald, there's almost invariably a test tube or a beaker in the picture. This is this is our mental model of the scientist. And so when Americans tell me you are their most trusted source of information about global warming, and they can't name any one of you, sorry not to pick on anybody personally, but they can't name any one of you or any other scientist for that matter, this is who they're thinking about. And that is problematic, and I'll tell you why I think it's problematic. The event that my good friend Susan Hassel would just blanch if I actually read the C word in the title of this slide, the event that we now call the CRU hack, actually Tony and I have done research to study the impact of that event, that public affairs debacle, and the net is that about 12%, 13% of Americans actually came away from that event with reduced trust in scientists as sources of information about global warming. It wasn't the Americans who came away with a reduced sense of trust in you as sources of information. As Susan suggested earlier, it was politically divided. People who believed that climate change, who had strong belief that climate change was real, were much less likely to suffer an erosion of trust. Liberals were much less likely to suffer an erosion of trust. Conservatives were much more likely to suffer an erosion of trust. We've shown the same thing earlier this year in a paper in BAMS. We showed the very same phenomenon among Americans' television weathercasters. And it got us thinking over the course of the past several months, well, what is it about Republicans who actually haven't yet wandered off the ranch? What is it about Republicans who have been listening to you, who, like you, believe that the climate is changing, that it is human-caused, and that it might even be a real serious problem for humankind? So we sort of flip the coin on its side for a little while, and we examine that in our data, in our national survey data. Who are the Republicans who are convinced, who remain convinced? And I'm not going to go over all of this, although I do want it known that somebody's going to show some p-values and some beta coefficients and an r-squared in this talk today, and that would be me. But all I want you to pay attention to are the two most powerful factors that predispose Republicans to be convinced that the climate is changing. Number two in the list is trust in you as sources of information as climate scientists, so they trust you. And number one is the point that John was making, understanding that the vast majority of climate scientists are of one mind in being convinced by the evidence that the climate is changing, that human actions are driving that change this time. And holding those two key beliefs are the primary predictors of Republicans who get it versus those who do not. So, pop quiz. Who is Canada's most trusted person? Thank you. That's the first time I've ever asked that question in public and received a right answer. David Suzuki, quick show of hands, how many of you know who David is? This is a very unusual group of people. David is not once, not twice, but the past 3 years in a row has been voted by Reader's Digest in Canada as Canada's most trusted person. And I love what Jackie Fitzpatrick said as to why. He knows how to reach out and explain things so the common man understands. But at a deeper level, I want to sort of draw the real lessons from this. David is a wonderful guy. He's an expert, certainly. But fundamentally, what I think is going on, why David has been voted Canada's most trusted person 3 years in a row, is David is extremely familiar. He is familiar. I'm sorry, I forgot to mention that on the past slide. For 22 years, he's been the host on CBC of The Nature of Things. He comes into Canadians' living rooms once a week and has done so for the past 20-some years. He's familiar. Because he's familiar, he is liked. That comes from social psychology, the first class any of you ever might have had in social psychology. In the second social psych class, you learn that people we like, we tend to trust. Therefore, this familiarity of David working this public communication venue of his called The Nature of Things has earned him extraordinary trust in the eyes of his fellow Canadians. He's familiar, liked, and trusted. And I would say proof positive, the fact that David has been elected Canada's most trusted person for the third year in a row, when climate scientists in the United States are suffering some loss, erosion of trust as a result of the CRU hack, tells us a lot about the importance of trust in maintaining people's, the importance, of familiarity in maintaining the public's trust. So all of this is simply to say, if you feel it is important to share what you know about the changing global climate with the public or with other smaller groups of stakeholders, you are forced to grapple with the question, how can I gain more face time with these people? What can I do to become more familiar, more liked, and more trusted? And I've made this point before to other climate science audiences, and often they don't like the more liked part of my contention. They feel it is not their job to be likable, but I would suggest if you want to be trusted, you have no choice but to find ways to be likable, because those two qualities are so closely intertwined in the minds of the people you are trying to reach out to. So the second point I want to make is that the less you say, the more you are heard. I guess I'll just stop right there. I'll let you meditate on that for a little while. My core training was in the field of public health. I came to communication research because I was a committed public health professional, and in my life as a communication researcher in the field of public health, I learned the lesson at the bottom of this slide, that the public education initiatives that we have succeeded in public health over the past number of decades have all had the following qualities: simple, clear messages repeated often by a variety of trusted sources. simple, clear messages. It all begins with simplicity. The less we say, the more we are heard. So if you want to find ways for the climate science community to embrace this formula, we got to figure out what is most important to say. We have to find other trusted voices who are willing to say it with us. We have to say it early, we have to say it often, we have to say it every time we have a communication opportunity. It isn't left for somebody else to do this work. It is each and every one of our responsibilities to explain what is important for everyone to understand before we go on to explain what is new and sexy and glittery. So, the third and final point that I want to make, if it's worth saying right, meaning it is worth doing the audience research to figure out what is going to have the impact that we hope to have, and those relatively small numbers of us who are doing communication research on this question, more or less, there's a little bit of disagreement around the edges, but more or less we have converged on these 5 message points on this slide as what on my team we now call the Big Five. Every one of my students, every one of my postdocs, every one of my colleagues, we all talk about this as the Big Five. We know exactly what we're talking about, and we know how to rattle it off in our sleep, because these are the beliefs that influence the public's public engagement in climate change. Global warming is real. Global warming is, I'm sorry, when I talk about the public, I almost always say global warming, but actually I'm talking to you, I should be saying climate change, and I actually think you should be saying climate change too, and if in the discussion you ask me why, I'll happily tell you. Climate change is real, people are causing it. The point that John made, there is widespread agreement among all of us that this is happening. It is harmful to people, and this is a solvable problem, Susan's point earlier in the session. These are the 5 key beliefs that distinguish members of the public who are deeply engaged in the issue and are ready to personally take part in action to address the issue, and are willing to see our society move forward with solutions. Last week, we had a paper published in Nature Climate Change. It's a particularly important paper, in my humble opinion, because it shows one thing, and that is the reason, it used to be the Big Four, the 4 key beliefs in the middle of this slide. We added the 5th belief that we call perceived scientific agreement. In other words, understanding that the vast majority of you agree that climate change is real and human caused. This paper unpacked why that is such an important belief, because there is a widespread myth held by 2 out of every 3 American adults that you all disagree, that there's a lot of disagreement among members of your community about whether or not climate is changing. And people who hold that myth, it erodes their other key beliefs. It erodes their belief that it's real, that it's human caused, that it's bad for people, and that it is solvable. So this has been the talking point, as John was suggesting, of the climate denial campaign over the past 10 years. And it was a particularly brilliant communication strategy, because they picked one talking point that torpedoed the 4 most important beliefs that undermine public engagement in this issue. I don't yet know the best way. I'm laughing to myself because John actually got to my slides before I could get it. There are a number of ways we can make the point that the vast majority of you agree that climate is changing and it is human caused this time. We can represent it in traditional ways. We can represent it in the way that John represented it. We can use analogies. Analogy about if 95 out of 100 doctors told us that our child was sick, would we ignore them and go with the 5 who were, or some proportion of the 5 who are giving us alternative opinions? If 95 out of 100 engineers told us this bridge is not safe to drive over, what would we do? I think there are a variety of ways we can make this case. I would like to see us my research team is actually planning on doing the research to figure out what is the best way to de-bias, debunk this myth that John introduced you to. Really important. So, in conclusion, again, if it's important for you to spend your time sharing what you know with experts outside of your discipline, I urge you to think more about and to take time to cultivate trust. We can talk about that during the question and answer. Happily talk to you at other times about what you can do to cultivate trust. But that is an important part of the communication equation. The less you say, the more you are heard. And the 5 points that I want you to consider saying are these 5 key beliefs that essentially are the underpinning of public engagement in climate change, none more so than the one key belief that was formulated as an overt lie about what you all believe. The fact that there is widespread scientific agreement in your community that the climate is changing and human activity is causing it this time around. If you want to know more about it, we keep all of this stuff on our website, free for your download, if you're really interested in hearing what I was supposed to talk about, the Global Warming 6 Americas, I put all of those slides in my deck, but I'm not going to talk about them, but you can find them on the AGU meeting website. So thank you. I think I'm going to let you talk. Yeah, we'll let you do that since you were so good at it.
So as stated earlier, we're going through all 4 speakers, and then we'll have everybody come up to the desk and address questions. The 4th speaker is John Reisman, my co-convener. And John's going to talk about context and relevance in climate communication. You ready to go, John?
The reason I wanted to talk about context and relevance is that we're really losing the battle a little bit on getting across past some of the myths. And for example, one of the issues is, I remember John Coleman said, there's only a tiny fraction of CO2 in our atmosphere. Does it make a difference? He doesn't think so. But if you remove that CO2, we have a frozen planet. You can keep all the other greenhouse gases. We literally are frozen at that point. And it's a very small amount of CO2. The other issue in communications, of course, is complexity. And regular humans would look at these formulas and say, well, at the bottom it says forcing equals fish, triangle, T. And that's pretty much it. I mean, they don't get past that. So we have to simplify the message. And I like to talk about the sweater effect. I didn't have a picture of a sweater, sorry. But we put on clothing to keep warm. Okay, you add a little CO2, you keep warm. You take away that CO2 from the planet, it's very cold. And think about a sweater as the troposphere. Because that sweater literally covers your body, and you radiate heat from your body into the sweater. It re-radiates it back towards your body. Above the sweater would be the stratosphere. And there we see, actually, because we're blocking more heat and keeping it from escaping, we're seeing it a little bit cooler. So that's actually a very simple methodology to explain the greenhouse effect. So we need to look for more simple mechanisms to actually explain these things. The relevant issues, and if you bring relevance into the equation, then what happens is people start to understand what it means to us as people, as a society. We have energy economics, resource economics, monetary economics, international and national security. And this all has to do with our standards of living. And it's very important to understand that without science, our standards of living would not be as luxurious as they are today. So science is extremely important, and I don't think we really sing the praises of science enough. The basic planetary systems are earth, wind, fire, and water. We get our energy mainly from the sun. In this, actually, the plants get a lot of energy. We eat the plants. Animals eat plants. We eat animals that eat plants. And that's how we get our energy. Sometimes those plants and animals get buried in the ground, and over millions of years they become oil or coal. In that case, actually, we're burning solar energy in our cars. So we're a solar-powered system already. What's going on with global warming, we see, for example, Admiral Titley already testified this year, 78% of the ice volume lost in the Arctic, it's gone in just the last 30 years, and that's a lot of ice. Of course, as we increased the radiative forcing, then we see the oceans warming up a little bit. 1.66 watts per meter squared. That puts more moisture into the atmosphere. And in doing so, of course, that increases and enhances the greenhouse effect. The CO2 goes into the ocean. Ocean acidification affects plankton, shell life, other systems. and it's affecting vegetation. And that's critical because what we're talking about when we start talking about vegetation is also the crops. The yellow areas on the screen are actually where we grow all our crops. The brown areas are drought events over the last few years. And as the Hadley cell expands, of course, we're going to be impinging more and more on those crop systems. In doing so, of course, we're losing soil moisture content and we're starting to drop crop yields. That's an economics equation. Hurricane intensity increasing and number of named storms also increasing. The soil moisture is a two-edged sword. We're dropping crop yields, and that's already in the numbers. And Chris Field will be here on Friday at the Climate Confluence Issues Talk, and he'll be discussing about a lot of these related issues. The other side is that when we lose the soil moisture content, we're increasing our vulnerability to fire. And that, of course, can affect our crops, as we saw in Russia recently. This also changes our net primary production. This is the carbon uptake of the planet. And NASA did 30 years of studies. The first 20 years of that study, actually, they showed that we increased net primary production 6%. The last 10 years, we showed a 1% decrease, and in the analysis I saw on the NASA website, they attributed that to fires and droughts. And this goes to the loss of soil moisture content. This is all about economics. The definition of economics people often misunderstand. It's not about money. It's about the wealth and resources of a country or region. It's about the careful management of those resources and the balance of systems and methods. We have our main economy as our resource economy. And the resources we trade include food and minerals and everything else, and we make products out of all of that. The secondary, or I would say a meta-economy, is our monetary economy, and we're operating on the Keynesian economic model. Why are all these things important? Because we're trying to talk about what's relevant to people in general. And our economy, inflation rates, and our food system is very, very relevant. We have a 2 Celsius limit. This is the speed limit for the planet, and this is a general agreement across the spectrum that if we go past that, we're going to see more serious economic impacts. And Richard Somerville just sent me this chart last week. He calls it the ski slope graph. The first line you see is the 2011 graph. If we start reducing emissions then to stay under the 2C speed limit, then we would have a fairly gentle slope. He calls that the bunny slope. Beyond that, we have the intermediate slope. That's the 2015 line, that's the blue. And the red line is the 2020 line. To stay under the 2C limit, we'd have to actually reduce emissions much faster, and that will have much more serious economic impacts. Why are people confused? It gets cold out. This actually was an El Nino event. People don't really connect the fact that when you raise the temperature of the oceans a little bit, it evaporates more water. More moisture goes into the atmosphere, and what goes up must come down. It's going to come down as rain or snow. If it's wintertime, you're going to get a lot of snow. So we're seeing larger snowstorms. We're seeing larger rainstorms. But we need to get past the dissonance about that, where people are confused, because these are absolutely connected. They say we can't attribute a single climate event or a weather event, I should say, to climate. Well, think about it. If climate is the car and CO2 is the driver, weather and natural variation are actually inside the vehicle. I consider them the kids in the back, and they're sometimes restless and sometimes more quiet. But we've changed the radiative forcing, 1.66 watts per meter squared according to IPCC AR4. That adds up to 26 zettajoules per year. So the car is definitely driving down a new road. All weather and all natural variation now occurs on this new climate path. The costs are increasing. If you look at the green line at the end of the chart, you can see that the billion-dollar events from the National Climate Data Center, as of October 2011, have already surpassed all previous records. So there is definitely an economic impact, and we need to pay attention to that, and we need to concentrate on what these things mean to us when we talk about climate change. I wrote a book called Exposing the Climate Hoax. It's all about the economy. And though it seems a little controversial, the reality is there is a hoax going on. And I actually often say there is a small oligarchy of scientists that are trying to trick us. Now, I detail a lot of the arguments that come from, for example, Roger Pielke Sr., Roy Spencer, S. Fred Singer, John Christie, and others, because they're missing context. They often say things like, it's not a big deal, or it won't be a catastrophe. But those words are actually meaningless. They never give you the context of what catastrophe means. We know that if you change the soil moisture content, it's going to impact our crop yields. And that is the issue, and that is an economics issue. Inside the book, I go over a myriad of contexts in various areas: science, economics, energy, environment, security, food, water, and infrastructure. And I like to give a lot of context to infrastructure because think about the last 10,000 years. We've been in a relatively stable period called the Holocene. So all of our cities and towns have actually been built up during that time. We've changed now the radiative forcing, 1.66 watts per meter squared, and NASA now has us at 1.8. That's actually 29 zettajoules, so we'll see how those numbers play out, but it's a lot of forcing. So that's going to impact our infrastructure in an economic fashion. I go into climate psychology with something I call the real climate gate, and that goes into detailed arguments regarding Sonja Boehmer-Christensen and the energy and environment reports. Also, of course, politics and policy. And science is the basis for policy. If we try to succeed or have policy that doesn't rely on science, we're guessing, we're making ideological decisions, or we're basing this on belief. And that doesn't work for policy. We need to be operating off of the best available information. The Joint Forces Command actually has shown us that we're already running into peak oil. So economics are very critical as well. We have to keep the economy working without breaking it too much, or else we won't get to mitigate things. We won't get to fix things. At this point in time, we're looking at just a few years away, and this is based on supply, demand, and refining capacity. So we have to make sure that we pay attention to the energy scenario as well, because we need to convert the energy economy and infrastructure. Political issues include campaign reform and special interests. And there's a lot of influence from special interests in the political side now. So we need to pay very close attention to that, and how do we actually get past that so we can get back to relevant policy? The risk, of course, is passing the speed limit. And the further we pass the speed limit, the more expensive the fines get. The ski slope gives us a very good graph and actually a guideline to try and point towards mitigation and policy that will achieve that. Jim Hansen was here last year and he said we need a third party. So I set up something that says, all right, we need a pragmatic party. Now, something based on reasoning and science and what's the best information available. It's not an ideological-based system. It's just what can we do to be pragmatic. When I do talks, often I hear things such as, well, now that we know it's serious, someone should do something. And that someone is us. And that someone is you. And that someone is me. We all need to be involved in understanding all these different contexts. We're talking about energy, we're talking about economics, and we're talking about climate change. They are all critical issues. They say, for example, or I've heard many times, you never know what you can do until you try. So delve into these relevant issues and see what you can do. As for myself, I've decided to run for President of the United States in 2012. To test that thesis, and let's see what we can do. The speed limit is 2 degrees Celsius. If we don't stay ahead of it, it's going to get very expensive. We need to pay attention. I'd like to at this time also apologize right away to the AGU for bringing up politics on the podium. I did not have permission to say this. I did it of my own accord. But it's also important to realize that if we don't pay attention to these issues, we're going to break a lot of things. And we don't want to do that. And I couldn't think of another place or a better place to talk about starting a campaign for reason than a science organization such as the American Geophysical Union. Thank you.
Okay, so now we can bring the lights back up if we know how to do that. And we'll open the the floor to questions from the audience, and we'll bring up the panel to answer your questions. And what I'm going to ask the panel members to do is to please come to the podium. And what I'm going to do is have a hand mic to be able to try to be here to help you. Okay, can we get the first question? You see one? Yes. Susan.
I think the question was, how do we get people who already understand that the climate is warming to understand that it's caused mainly by human activity? Is that your question? So I explained, it depends how much time you have, of course. But we have many ways of knowing that the warming that we're seeing is due to human activity. And I think, as John Cook suggested, you have to boil this down. You don't want to give too many answers, and you don't want to make them too long and too complicated. But what I tell people is, we know what's caused those climate changes in the past. None of those are operating right now. In fact, if it weren't for human activities, we would actually have seen a cooling in the climate over the recent past century. Most people don't know that. Even people who accept the science of climate change think that we're in kind of a natural warming cycle and maybe we're spurring it along a little. It's actually a very common misconception. So I usually explain that. I explain how we can use climate models to simulate the climate of the past. And when we take out the human activity, the human gases contributed, then you see a cooling. And only when you add the human factor back in do you see the warming that we've actually seen. That's one way. Another way I explain it is that there are fingerprints for different kinds of causes of climate change. So if, for example, the sun were causing this warming, the pattern of warming throughout the atmosphere would be warming at the surface, warming in the layer above the surface, and warming in the stratosphere. That's not what we see. In fact, what we see is warming at the surface, warming in the troposphere, cooling in the stratosphere. That's a fingerprint that it's from the human-induced buildup of heat-trapping gases in the atmosphere. People don't know that. It's pretty simple. It uses the fingerprint metaphor. You're finding the culprit, just like they use fingerprints in a crime scene. And I find that to be very effective at helping people understand that we understand this cause. And so those are two examples, and I'm going to let others make comments as well.
Go ahead, John. Yeah, just step forward.
I'll take one on that also. On top of the shorter-term natural cycle, and looking at, for example, solar, if you look at the longer-term Milankovitch cycles, that's the axial tilt and the orbital forcing precession and whatnot, we're actually past peak forcing. So we already popped out of the ice age 10,000 years ago. It started 20,000 years ago. That peak forcing is now over. We should be slowly stable and or cooling for about 35,000 years when we would actually enter the next ice age. So at this point in time, actually, we're already past those peak forcings. We should be stable or cooling, not warming.
Okay. Next question. Yes.
Winters
Yeah, so the question is about climate variability as opposed to climate change, and the fact that because there's been some cold winters, that makes people reject what happened to global warming, right? So the thing to do is to explain to people the difference between weather and climate. The kinds of variability you're talking about are weather. Global warming doesn't outlaw winter. We will still get winter, and it will still be cold. The way you judge climate is by trends and large-scale changes. So, for example, the work that Jerry Meal and Claudia Tebaldi did that shows that over the past decade, we've broken 2 heat records for every 1 cold record. That's what you see in a warming climate. It doesn't mean there won't be any more cold. In the past year, we've broken 3 heat records for every 1 cold record. That's what happens when the climate's warming. If the climate were stable, you'd get 1 record heat and 1 record cold. They would be even. But what Jerry Meal likes to say is, you're still going to get cold events, even as the climate warms. Even by the end of this century, Jerry says, who's ever sitting at his desk at NCAR, at the end of this century, when we're breaking 50 heat records for every 1 cold record, when 3 months out of the year, it's 100 degrees or more across the whole south of the U.S., there's going to be 1 cold day in Denver, and somebody's going to call the person sitting at his desk and say, what happened to global warming? So we're still going to get occasional cold. You just have to explain that to people. Okay, so yes. Yeah, so right. Yeah, so the comment is that we should all focus more on explaining climate variability and climate change, the fact that climate change is superimposed on a naturally variable climate, and that it's still going up and down, but the long-term trend is up. And I agree, but when you get 10 minutes, you can't cover everything, and Ed and I are big on simplifying and only focusing on a few things, so that's why we didn't focus on that today.
There will be some other sessions that also get at natural variability and particularly extreme weather in relationship to climate that will also touch on those issues here. Yes, back there. So the point raised is that there are different flavors of climate deniers. In fact, I have seen single speakers do all 5 of the different things you just mentioned. So all in the same talk. So I don't think it's between people. It's just maybe part of the overall argument. But please, Ed.
So actually, perhaps John Cook should speak to climate deniers as people who are committed to a point of view and committed to winning the battle of ideas. I'm not going to speak to that part. But instead, I'll give a preamble, which is to say that the vast majority of Americans, and pardon me for focusing only on Americans, but that's who I study, the vast majority of Americans, specifically the 4 groups in the middle of our heuristic that we call Global Warming 6 Americas, that's about 75% of all Americans, they just don't really have a strong set of beliefs one way or the other. They're certainly not motivated reasoners, people who are looking to tease apart the arguments and counter-argue. They, generally speaking, aren't paying a lot of attention. Generally speaking, they would like to know the truth. As I've already told you, generally speaking, they think you all are not in agreement as to what the state of the climate is. And the reason, I believe, a big reason underlying all of that is because we haven't shown the discipline in the climate science community to learn to speak in one voice about what we know about the nature, the state of the climate. It's not a natural act for any type of scientists or any scientific discipline to do that. I accept that as true, but in this case it's very important that we learn to speak in one voice to explain to that 75% of Americans who are basically not convinced strongly one way or the other and are laboring with the misperception that you all are disagreeing. So for me, I'm much less interested in the sort of the motivated and organized opposition who are intentionally trying to obfuscate than I am in trying to solidify what the Brits call the wobbly middle, and believe me, it's a very, very large middle. And they have an open mind and they would like to know what you have to say.
Just a
Yes.
quick addition to that.
Oh, sure. Let's have John talk.
When I started the site in 2007, we actually built a database of climate myths with that exact structure, with the it's not happening, it's not us, it's not bad, and then it's too late. And my expectation was that over time, the public discussion among climate skeptics would gradually move along that spectrum. But what's actually happened is it's kind of shifted around, and it's still in the first state. I think there are still a lot of climate deniers who would even say that it's not happening, that we're experiencing global cooling at the moment. And I actually thought that by now my site would be obsolete and that the science would be undeniable. So I think that it's that saying that people whose views aren't based on facts and evidence aren't swayed by facts and evidence. So I think that's why understanding our audiences and what drives climate skepticism or denial is an important thing for communicators.
Very good. Here?
Yes, John is planning revisions to the climate skeptic presentation on the website based on this knowledge of repeating myths actually.
Yeah, so we've been building this whole database of debunkings of climate myths over the last 5 years, and only over the last few months have I summarised it all into like a debunking handbook, all the points that I argued today just in a single little booklet. And so, yeah, we basically have to kind of revise our whole website and kind of just tweak the way we've structured the content so that, yeah, just to be aware of all these different backfire effects. So we've got a lot of work ahead of us, unfortunately.
Back there? Yeah, you two are fine. Yeah. One of you, right there, you standing up.
Much of what you presented was about improving our message, to some extent being better messengers by perhaps being more likable and more trustworthy. My question is, are we really the right messengers in many cases? If the people that we need to be convincing are more likely to be accepting a message from someone who shares their common value system, and they can look at me and say, well, you just don't look right, you're a nice guy. Maybe we should, how would we as scientists reach out to church leaders, to business leaders, civil rights leaders, retired persons leaders? Aren't they the ones who need to be the messengers? And what is it that they need to hear from us? And how can we reach them to enable them to give those messages to their followers, people with whom they share common values?
It's a great comment. For if anybody didn't hear it, it's about messengers and the fact that scientists are not the best messengers for many cultural groups, and how can we better partner with those who are. And so in my experience, when scientists work with people like members of religious organizations in the faith community, business leaders, national security leaders, union leaders, and others, that's where you get the best results. Once you educate and help get those people on board, answer their questions, and they become committed, then you get these fabulous campaigns that are driven by those messengers. And that really is who people are going to listen to. So you have Sally Bingham, the Reverend Sally Bingham, who started Interfaith Power and Light. And they do this, fabulous work. And so I think you're exactly right. I think the main role for scientists in many of those cases is to educate those other messengers and to partner with those other messengers. Others want to jump in?
Oh, please. Yes.
That was a lot of what I was talking about related to that particular issue, because we need to talk about, and others brought it up already, the values that people care about in their particular cultural segment. And when you're looking at the Republican side, for example, they really are very concerned with the economy, and we have serious economic situation going on all around the world now. So if we as scientists, and that's why I did the presentation just the way I did it, we must relate to the economic side of it. And I mean we as scientists as in you, I'm just a communicator. But if we don't address the economics of it, if we don't start to convey to them what this means to crop yields, then we don't actually get the connection to the economy and how it affects us and impacts us through time, because this is an inertial problem. We have loaded the system with a lot of energy now. We need to somehow get that across better.
Okay, we had another one right here. Yes.
So my understanding of social movements is, in fact, a minority of people can influence the majority. So the wobbly middle in Brits can be influenced by a small minority of 5 or 10%. And so we're seeing these climate deniers having a remarkable influence on the conversation. And from what I gather from you, and I collectively, that it may not be worth our while to try to confront the climate deniers because they'll never move. And my experience, having interacted with some of these climate deniers, is that in fact they wield a tremendous amount of influence on the conversation. So the wobbly middle might be easy to influence, but isn't it important to somehow reach out to the climate deniers and somehow try to move them towards truth and reality and beauty?
I'll say a quick comment, but I'd be interested in hearing John's answer to this too. But what the strategy we've taken, which I think is the most practical one, unless you're a certain type of person, I guess, is that like the research shows that it's very difficult to change someone's mind when it's all tied in with their worldview and their sense of identity. And so I see trying to change the mind of someone who's firmly denying climate change is a waste of time, basically. And so I think the effort should be concentrated on reducing the influence on this wobbly majority rather than trying to change the mind of this unshiftable minority.
Talking to members of Congress, congressional staff last year after the new Congress came in, I mentioned that I would be happy to get a kind of task force of scientists to come in and talk to them about climate and why the science is important, to just talk facts and answer their questions. I was told that the House was not interested in such an event. So
can I just make a quick comment on the term denier? I spend a lot of time working with the nation's television weathercasters, and as many of you know, they hold a variety of different opinions about what they call AGW, anthropogenic global warming. Some of them feel very passionate about the fact that human-caused climate change is not happening. I met one of them face-to-face recently, and in a small group setting, he let me know in no uncertain terms, and others, we were actually in a conflict. We were engaged in a conflict reduction workshop at the National Weather Association annual meeting. We had intentionally recruited weathercasters who held a diverse perspectives about climate change, and then he told us very, very clearly that he considered the term denier to be a hateful term, an absolutely hateful, unacceptable, slanderous term that is used purposefully to paint he and people who share his beliefs, paint them into, essentially into the same lot with Holocaust deniers. So I just bring that up to say that we need to be very careful about the words we use. I understand that we all feel very strongly about this issue, but sometimes we use words that provoke a fight needlessly. A fight that needs to be fought is understandable. Provoking people who feel equally as strongly as we do in unproductive, counterproductive ways is not a good idea. And that the term denier, and I realize there are paid deniers out there. John has mentioned some of them by name. But most people who don't share our views on this issue are not paid deniers. They are people who are unconvinced of the evidence for a variety of different reasons. And I'm not sure we are going to succeed in convincing them based on the evidence or any other method, but what I am absolutely sure, because of these conflict reduction workshops we've been running within the AMS and NWA broadcast membership base, is that when we essentially create a conversation among people with different points of view, and we enforce one basic ground rule, which is we will treat each other with respect. And if you violate that ground rule, the moderator is going to call you out on it, and it's usually people who share my views about the evidence on climate change that are the first to break the ground rule. It has this wonderful, wonderful catalytic effect on allowing the wobbly middle, and we know they're in the public, they're also in the weathercaster community. When the wobbly middle feels like the two ends of the acrimonious continuum are going to be respect-based dialogue is going to be enforced, then the people in the wobbly middle suddenly sit up. They start paying attention, they start raising their hands, and by the end of this particular workshop I'm talking about, at the end of the workshop we had every single person, 25 people in the room, go around and tell us what they learned from this workshop and what if anything they'll do differently. The very first person to speak was from the wobbly middle, and he said, for the first time tonight, I got it, that whether the climate is changing as a result of human activity or not is really largely irrelevant to me as a weathercaster. I am an important part of the safety fabric of my community, and I do believe that the climate is changing, the weather is getting more unpredictable and to a large degree worse in my community. I now understand that is my responsibility to make sure I am sharing what I know with my viewers. That was I don't know if I told the story properly or not, but for me, that was a really important experience in understanding just how dysfunctional it is when we start pointing fingers and calling people deniers.
I like the fact that you're talking about, talking to that particular segment, because most people are actually not deniers. They're actually skeptics. But people are more adamant and more noisy on one particular side of the argument. But these people do care about the economy, so we really need to address them very directly with the facts. This is what's happening, this is what's going on, this is what causes it. But relate it, if we can get more and closer to the relevance issues, as I was describing also, we got to talk about the economy, we've got to talk about the impacts so that they understand the timescales and inertias. And it's difficult because you actually have to study as communicators how we're going to get that across. You need to know the scopes of each particular area. And some of these are still qualitative arguments, but we need to engage. Most people, and I want to repeat it, most people are not denialists. They are pretty much just skeptics. They are hearing facts out of context, and therefore it confuses them.
Yes.
Yeah, so the question is about sort of the order of events. You have to talk about the problem, but you have to talk about the solutions, and if you start off talking about climate change, people get turned off. So I think this is interesting. I'm going to talk about it tomorrow in an education session that deals with the question of values in framing of climate change. And I think the best example is a story from Kansas. There's a woman named Nancy Jackson, and she started a project called the Climate and Energy Project in a really red state, Kansas. And it was written up in the New York Times, and I really suggest that you all look into it. But what she did was she understood that she could not mention global warming, and you do not want to mention Al Gore when you go in these communities where she's working. But what she found was that she could really get people interested and excited in reducing emissions by tapping into their values and things that they care about. Thrift, building good jobs in their community, all kinds of things around that, good stewardship. And you know what? They had a lot of fun doing it. They did things like they had on Halloween, they did things pegged to holidays. On Halloween, the kids would go looking for vampire electric loads, those things that suck energy even when they're not, on or something. And they had contests. Which school could save more energy than the other school? Which town could save more energy than the other town? And before you knew it, they would save 5% of the electricity around there, which is a huge deal. If you know anybody who's ever worked on energy efficiency programs, that was a major success. They never talked about climate change. It was all about climate change, but they didn't really talk about climate change. I think eventually you do want to get around to talking about climate change because you can come up with the wrong answers, right? So if you say, oh, it's national energy security, people say, well, we got plenty of coal. Let's make synfuels, right, or something. Yeah. So eventually you do have to talk about the carbon dioxide problem, I think. But it doesn't have to be the first thing out of your mouth. If the front door is blocked, you find a side door. And as you build trust, Ed talked about the importance of trust, as you build trust with people, and they understand you're not there to do something terrible to them, and they're having fun, and they're saving money at the same time, and they got a wind turbine factory, and they got 400 new jobs, and the farmers are renting their land to put the turbines on, and they're getting money in their mailbox, all those things are happening. Now they're listening to you. Now you can have a conversation about climate change. So I think you don't have to feel like you have to barrel in talking about climate change first thing. I think eventually you have to get around to it, though.
Just a quick, this is more anecdotal than rigorous, but I used to have a lot of arguments with my dad about climate change, and he was a climate skeptic. And then one day he said, son, I believe that humans are causing global warming. And so, fascinated by this, I asked him what changed his mind, and I was hoping I could open up his brain and kind of unpack what causes a skeptic to change their mind. And he said, oh no, I've always thought this. So I kind of had to deconstruct his thought process, but what I think happened was he put solar panels on his roof, and he worked out that he was actually making money from solar power. So somehow that just shifted his whole view on the science. It makes no sense, but I think a lot of people can come to the final destination in a lot of different paths.
Very good. Way back there.
There was an awful long table to explain why you'd rather retire the term global warming in favor of climate change. Can you explain that to me? I'm not a specialist in this.
I'm drawing a total blank as to who did the research. Karen, do you recall? I'll tell you what the research found, and perhaps my colleague Karen Akerlof will remember the author's name. A study that essentially a public opinion poll in which a randomized experiment was embedded. The experiment was fairly simple. It simply switched out the terms climate change and global warming, and conservatives are 20 percentage points, not 20%, but 20 percentage points more likely to acknowledge that climate change is occurring than they are likely to acknowledge that global warming is occurring. Karen Akerlof and I published a paper in Climatic Change Letters earlier this year looking at people's preferences for the terms global warming, climate change, global climate change, and what we found is that in the group that we call the alarmed, the 12% of Americans who believe deeply that the climate is changing, that it's human caused, that it's a threat to not only people in general but to themselves and their members of their community, they actually do have a strong preference for the term global warming because it is a very affective term for them, and they feel they've got strong affect about the issue. The rest of the public, generally speaking, has no preference one way or another, with the exception of real strong conservatives, and they prefer climate change, we believe, particularly because it is not an affective term. So the reason that I now recommend, Karen converted me on this one, I now recommend that climate scientists actually talk about climate change rather than global warming is because it is the term that is more likely to allow you to sustain a real meaningful conversation with Republicans, with people who are, for whatever reason, their political ideology or otherwise, are not convinced of the evidence.
We all are succeeding because I saw a denier warning about how these sneaky trying to change the term of the debate. So you're having an effect there.
Well, I want to add something to that. I think there's a reason that conservatives don't like the term global warming and that they prefer the term climate change. Climate change sounds more natural. And in fact, even scientists would suggest that climate change includes any kind of natural climate change. Global warming is specifically referring to human-induced global warming. So it's not just semantics. There's meaning here. And as for those people who say that it's us sneaky people trying to change the term, the truth of the matter on that is it was Frank Luntz. Now, I've said his name 3 times today. It was Frank Luntz in a memo quite a while ago who said, he told the Republicans, he was advising the Republicans, use the term climate change. It sounds less scary than global warming. Don't use the term global warming. So it was actually a Republican strategist who tried to get the term climate change in. So they're rewriting history. That's really not what happened.
You know, one further thing on that is that the scientific community, by and large, has always preferred the term climate change because it also allows for all those severe events and so forth that we know is part of the climate, whereas the term global warming, which was kind of developed by the media, kind of sounds warm and fuzzy and doesn't really convey the whole picture.
Climate disruption is probably the best of all the terms that I've heard. John Holdren uses it, and I think it's good. I actually often use the term global warming just to set the stage because people know what you're talking about when you say global warming, and then I switch to climate disruption. But I do understand what Ed's saying about the fact that it's a charged term for some people and turns them off, and mostly I say climate change.
Okay. Any other questions? There's one right here. Well, we actually have one back there. Okay, let's do that one first.
Sure, absolutely. The wobbly middle has to choose. That's what it is to be human. You have to decide who you're going to believe and what evidence you're going to believe. But right now, the climate denial campaign, the organized climate denial campaign, is a very highly disciplined effort, and they really do have their top 5 talking points, and they hammer them over and over and over again. Simple, clear messages, repeated often by a variety of trusted sources. They have the formula, and they're implementing it. I would suggest that members of this community, members of the climate science community, have no choice but to learn from the other side on this issue and do exactly the same. Way back at the birth of my field of communication research around World War II, some of the early communication researchers showed that one of the conditions one of the conditions whereby propaganda works is when a set of messages is unopposed. They call it monopolization. When you can monopolize the airwaves with your point of view, propaganda, which I know is a very ugly term, propaganda can be very successful. I would suggest that the climate science community has not done nearly a good enough job yet in developing simple, clear messages, getting them repeated often by a variety of trusted sources. Although, that said, I would say the year 2011 has been a really hopeful year for me because I see the climate science community recognizing its lack of discipline on this point and organizing itself to become much more disciplined. And I'm hoping that 2012 becomes the year in which the climate science community does embrace that formula for effective public education.
Okay. We have a question back here. They talk about science.
Yeah, Hunter, I think we do have to talk a little bit about the science, and I think that there is some science in Ed's 5 messages. I mean, the fact that the world is warming, that's based on science. We got 10 different ways of knowing the world's warming, and they're based on science. The fact that we know it's human activity, and somebody asked me that question earlier and I answered it, that's based on science. That's how we know that the warming is due to human activity. The fact that there will be impacts and it will be bad for us, it's science. So to me, all of it is science. But I think we can talk about science in a way that's effective, and that's why I focused all my remarks today on the solution side and the values questions, because that's also science. It's the science of communication. And so to me, this is all science, and that I know the public doesn't want a science lesson, but they do want to understand the truth, and they do want to hear about things that affect them. And so I think that's what we've all been trying to talk about here today. No, Ed, did you want to answer?
To add on to that, I mean, the reason we did this particular session, and I wrote it in a specific manner to give us a broad enough scope so that we could talk about relevance issues. So the science side, of course, is very important because people actually need to understand that. I don't really want people to believe in global warming. I want them to understand what's really going on based on the math and the physics and what we see in the science and the process of the scientific method. But the relevance issues are key. And as scientists, I'm hoping that the group here, and those of you that are scientists, will actually take to heart the idea of discussing relevance. Because we know the quantitatives on the science side. Start discussing what that actually means in the economics. We need people to stretch out a little bit and say, all right, what will that impact? And by doing so, people will start to assimilate that message.
Okay. Back there. Yes. Right, no, it's you.
I agree with everything you've said, although I do want to say that in graduate school, we are taught to become little warriors for our own research ideas, for our theories, and we do battle with each other. We do battle in venues like this. We're often not very nice to one another, and more than anything else, we've learned to speak a very rarefied form of the English language that simply doesn't convey what we understand to broader groups of stakeholders. So I'm not suggesting that we become evangelists. That part of what you said I don't actually embrace. I'm simply suggesting that we learn some new skills on how to communicate effectively, and we find the basis on which the vast majority of us do agree based on the evidence, and then we make that clear. We find appropriate ways to simplify it. We say it often, and we find the trusted others who will say it with us. And the earlier point about are we even the right messengers, that was a really great question. And I would say we are necessary messengers, but we are not sufficient messengers. So when those 5 message points that I laid out, I don't want the climate science community to be the only messengers conveying those 5 points. But if we are not conveying them, how can we expect the faith community to do so? How can we expect the risk managers, whomever they are, to do so? How can we expect many other groups of professionals that essentially whose actions in total give shape to our collective decisions to carry this unless we are right there with them, because it's ultimately your research and the other people in the room and the other people at this meeting that got us to the place where 97 out of 100 climate science experts are convinced based on the evidence that the climate is changing and it's human activity this time that is driving the change. So I don't really want us to become evangelists, because evangelism smacks of something that isn't authentic for anybody in this. I don't know who's in this room, but for most of us in this room. But helping others understand the truth that our research has uncovered is something that's authentic to us in this room, and it's something that I think we can all do.
So I agree with all that. And in addition, I think when I try to teach communication skills to climate scientists, 3 of the things I say that mistakes they often make is not putting new findings in context, focusing on areas of debate at the and not explaining to people the basics of what we know. And so that leaves the public with the impression that everything is under debate. So I think nobody wants to suppress anybody's ideas or not ever talk about debate, but you do need to place things in context for people because people don't know the basic issues.
The one point that I wanted to bring up is you as a scientist, you can bring up the confidence levels, basically from the confidence interval. We know where the science is on the 90%, the 95%, or the 99% virtual certainty. So you can actually use that as your guide to say, look, this is where the science is on this. And that might help. I mean, we don't want to be propaganda artists. We want to actually get the facts across.
Okay, let's have one more question and then we'll call it a day. Right here.
I think there are a couple of messages which are almost uniformly counterproductive and shouldn't we stay away from. One is to argue that the loudest voice, contrarian voices, are financed by large financial stake. Whether it's true or not, it's counterproductive until somebody finds a $50 million check signed by somebody from somebody with the financial interest in this. And $1 million isn't enough. It's got to be a large amount, or stop talking about it. Because when I hear someone say that, oh, all the scientists are just in it because they can get government funding if they say the climate is changing. It just makes me so angry because I'm a scientist. I am not on the government radio journey, or whatever you want to call it. And I think we have a serious problem that we need to address. So I think someone making that argument just is not making sense. And I can see someone in the muddled middle who's saying, well, gee, I'm skeptical about this, and I'm not being paid by a big energy company or something. They can't be right with that argument. So that argument is, I think, entirely counterproductive and should be stayed away from. Another one, which is scientific, that I think is problematic, is discussion about extreme weather events. I suspect, they really are more likely to the world of climate change. However, it's really difficult to demonstrate that. You have to, it's a detailed scientific argument. How do you define an extreme event? And how do you look at records from the past in a convincing way and say, yeah, we've got more now than we used to? It's much easier for someone to say, oh, that's just weather. Whether it's correct or not, that's a much more convincing argument.
Is there a question?
Okay,
I want to address
okay. I might as well too.
just on the fact, I mean, we do know that the radiative forcing is increased. So, like I said, you can't get easily, or it's very difficult or nearly impossible to get direct attribution. Same thing with the cancer argument with cigarette smoking. But the reality is we've increased the radiative forcing 26 zettajoules per year. And actually, NASA has it at 1.8 watts per meter squared now, which will probably be updated in AR5. So that's 29 zettajoules per year. All weather and all natural variation is now occurring inside that new climate car on a different road towards warming. So while you can't have direct attribution to a single event, you can, with, I think, reasonable confidence at least, say that all these events are occurring inside that new radiative forcing schema.
Why don't you go ahead?
So I would point you to the 2009 report, Global Climate Change Impacts in the United States. It's the national assessment. 13 federal agencies, and very clearly the point is made that we have seen an increase in extreme heat, a reduction in extreme cold. We've measured it. We've seen an increase in atmospheric water vapor. It's attributed to human warming of the climate. More water vapor in the atmosphere, more of the events, more of the rain events are coming in heavy events. On average, a 20% increase in the amount of precipitation falling in the heaviest 1% of events. It's about 58% over the Northeast. It's high over the Midwest as well. These are measured changes. We are seeing more rainfall in heavy events and less rain in light events. It is due to the warming. So there are certain things that we can say. We can also say that those changes were projected by climate models, and they've happened. So we do have some understanding of changes in extreme events, particularly extreme heat and extreme precipitation. And we understand the mechanisms, they were predicted, and they've occurred.
Yeah, I agree with what Susan just said. In fact, I will be giving an invited talk at a session in 3005 room in Moscone West at 5:45 or something like that, where I'm essentially going to say the same thing. We have plenty of evidence that indicates that extreme weather is happening with climate change playing a major role in it. It's a fallacy to think that all weather today is happening from either natural variations or climate change. It's both that play a role. And we'll talk more about that later. In any case, I want to thank you all for being here. And that'll end this session. Thank you.